times 10 to the negative, if I had my glasses on, 37. Oh dear God.
That's quite a very small number.
That's like literally not soluble, period. Anyway.
That's very not soluble. And that's why this is probably going to form an equilibrium. Maybe a little one.
It's not asking for the equilibrium though.
Oh, is it not? No, it's not. I just remember learning to at school that that only
we went through that.
Only the insoluble and very slightly soluble things will form an equilibrium.
Mhm. All right.
Because otherwise they just all disassociate.
So we're looking at copper 3. No.
Copper 2.
We're looking at. I was writing the thing already. So we're looking at copper 2 with phosphate. So that would be copper 3 4 bracket 2. Remember, again, I know I keep drilling this into your head. This is where you have to do the crisscross because copper was with a charge of 2. Phosphate was a charge with 3. Now, to write down your charges of the molecule, you're going to swap where your copper is going to become a charge of 3 and your phosphate is going to become a charge of 2. Does that make sense?
You mean copper's already got 3, so you mean
that's the final product. No, that's the final product. Because if I'm going to write my equation, which we will, it's going to be copper 2 plus plus PO4 3 minus.
Yeah, that's what I meant. Yeah, that's right.
Yeah, but remember, if you're making the molecule, which I'm talking about right here, which I've highlighted, you're going to have to swap the charges because can you see copper was 2 plus, now it's going to be copper 3 plus.
Yes.
And phosphate was 3 minus, now it's going to be 2 minus.
Yeah.
Perfect. All right, amigo, let's keep going. So,
yes.
We've been given our KSP at 25 degrees. Our job is to calculate the concentration of copper and phosphate in a saturated solution of copper 2 phosphate. So, in theory, that's a fancy way of saying find S for both of the ions.
Yep.
All right. Let's do this. As we did, we're going to firstly do copper. Actually, no, we're not. Is this molecule really nicely balanced? Is it?
We have 3 and 2 plus. No, it's not.
Perfect. So firstly, let's balance it.
So I'm going to put a 3 in front of the C of a copper, and then I'm going to put a 2 in front of the phosphate.
Like this?
So we have, cool. Yeah.
So let's double check that quickly. We have 3 copper left, 3 copper right, 2 copper, no. 2.
Oh yeah, I need to do, in front of there, I need to change what I've got as my, what is it called? My products. I need to change what that is as well. Maybe we can put a 6 out the front there.
Why are we putting a 6?
Because our charges for each of them will be 6 plus and 6
You don't
minus.
have to worry about the charges. It's asking about the number of atoms. So remember, there's 3 copper on the left. We've got now 3 copper on the right.
Oh yeah.
You're good. Don't overcomplicate.
Yeah, but then why would it why if we're gonna have 2 plus and then it's gonna be 3 minus, won't it then become my salt will be still a little bit charged, will still be minus if they're not the same, if my 2 plus 3.
That's okay, because remember, we're not talking about neutralization reactions here.
Okay. It doesn't matter if it's not neutral? Alright, cool.
Not everything's neutral. That's why we have a pH scale. Not everything's neutral.
That's right, yeah. Okay.
Alright, so we've checked that we've got 3 copper left, 3 copper right, and we've got 2 phosphate left, 2 phosphate right. So the next thing we're going to do is we're going to write out our S values for each of the ions that is present. So for let's do copper first, right? So what would copper be? What would its S value be?
Probably 3s squared, because there's 3 s's and they got the squared from there. Am I not right?
See, I'm not thinking that. I'm thinking that, I'm more leaning towards that it's going to be this.
3s. 3. Why 3?
Because there's 3 in front.
Oh, right, okay.
Because remember, you can have 3s because you've got 3 coppers in your product. And then the number that is down there, you're going to raise it up as a power, and it's going to become a power as well. So your 3 is going to become not only a coefficient, it's going to become a power. So you're going to have 3s cubed. All right.
Right. Okay, that's straight. Okay, that's what. So that's why in the last question it went.
That's why we had 2s squared.
Yeah, 2s squared because the 2 is in front and the 2 is the power. Okay.
Yep.
Right,
makes sense.
Cool. Yeah. So then we have.
What are we going to do here?
So it's going to be 2s squared.
Like that. Let's keep going from our little interval pause. So from your question, we've worked out again your S value for copper and your S value for PO4. So now what we're going to say is, why is it a pen? I don't want a pen. I want a text box. No, I asked for a text box. Thank you. I'm going to have KSP is going to be equal to, let's see if I can write this quickly, 3s cubed times 2s squared. Do you agree?
Yep.
Perfect.
Yep.
So now what we're going to do is we've got the KSP value, which is good, which means we can substitute the KSP value, which is
which equals our that times that.
Yeah, perfect.
Okay, which
so
will be.
Now we need to very carefully. This is the step where a lot of people make a mistake, is when we're getting a correct S value. So
I think it's going to be.
In this situation, step 1, let's do the first S. So we're going to have, let's do this one. No. Let's do this one first. So we're going to have 4s squared. I'm doing the one on the left. Can you see my mouse? I've just did this one.
Okay.
Yeah, wait. Yeah. So we've done that one. Oh, I have to restart a new box. Okay. And then the other one is going to be.
Why did it change to 4s squared, not 2s squared?
Pardon me?
Why did it change from 4s squared?
Because remember, you're squaring both the s and the number in front of it.
Okay.
So the next one is going to be 9s cubed. So
yes,
we're going to have. Oh, crap. Copy and paste that. No, I can't. So we have 1.4 times 10 to the negative 37 is going to equal to 9s cubed times 4s squared. Do you agree?
Yes.
Perfect. And now our last step is going to be 1.4 times 10 to the negative 37, which is going to equal to 36s to the power of 5.
Yeah, because you add the powers 10 times the things.
Yep. Now we just
Yep.
need to make S.
Oh no, you have to
That's gonna be
36th root.
fun. No, we're gonna divide it all by 6.
Oh yeah, we have to do that first. Right?
Yeah.
You mean 5? Oh no, you mean divided by 36?
We're gonna do this.
Because you have to get rid of it. You have to get S.
On its
You
own.
have to get, yeah, 30.
Yeah. So this is what we're gonna get.
Okay, that's gonna be crazy. 36 divided by. Yeah, that's gonna be very, very small number.
Okay, so I'm gonna do it with you. So I'm gonna get. Oh my god. Okay. 1.89.
I'm gonna get. Oh my. Okay.
I don't know.
Times 10 to the negative 39.
Yeah, I don't know where your teacher got these questions, but we're just gonna roll with it.
She probably just found some solubilities for those or something.
Yep.
Yeah, that's probably actually the solubility of that. So
But then
it's gonna be that.
We're gonna change that, and we're gonna put 5, and we're gonna not cube it, but I don't know how to even put it. You're gonna put the power of 5. So this is what you're gonna be doing.
Fifth root.
Yes. Dear God. And we're gonna get an answer of. Oh, it's actually quite a nice answer. Wait. 1, 2. Wait. 1, 2, 3, 4, 5, 6, 7, 8. So I got 2.079 times 10 to the
I got
negative.
2.08 times 10 to the 8.
Yep. Ta-da! That only took like 15 minutes.
Success.
All right. Done.